Welcome students. Today we will learn about carbohydrate molecules, which is also termed as energy source of living systems. So this is the table of content where we will first go through the introduction part of the carbohydrate molecules, then its function and importance, definition, classification, and some important carbohydrate molecules, their structure, properties, and preparation. These are the learning outcomes. From this e-content, we will be able to learn what is carbohydrate, importance of carbohydrate molecules in our day-to-day life, their classification, chemical structure of various important carbohydrate molecules, glycosidic bonds in carbohydrates, some specific properties like reducing and non-reducing properties, and its relation with respect to type of glycosidic bonds in carbohydrate molecules. So first of all, the introduction. Carbohydrates are the most abundant organic molecules found in nature. For example, sucrose is the carbohydrate molecule found in cane sugar. Lactose is the carbohydrate molecule found in milk. Starch is the carbohydrate molecule which is found in potato. As like these, various forms of carbohydrate molecules are available in our food. Carbohydrates are also called saccharides, which comes from the Greek word saccharon, means sugar. Functions and importance of carbohydrates. Carbohydrates are essential for life in both plants and animals. They form a major portion of our food. It is the most abundant source of energy, which provides quick energy to our body, about 4 calories per gram. Carbohydrates are used as storage molecules as starch and cellulose in plants, glycogen in animals. We build furniture, etc. from cellulose in the form of wood and cloth from the cellulose in the form of cotton fiber. Carbohydrates provide raw materials for many important industries like textile, paper, liquor, and breweries industries. Now, the chemical definition of carbohydrate. Carbohydrate term is derived from the French term hydrate de carbone, that is, it is a hydrate of carbon having the general formula CmH2ON. This general formula is applicable for simpler form of carbohydrates. Carbohydrates are defined as organic substances having carbon, hydrogen, oxygen, wherein hydrogen and oxygen are in the ratio of 2:1 as found in water. This definition has been derived from the general formula CmH2ON. These two definitions are the simplest definitions of carbohydrate, but chemically the carbohydrates may be defined as optically active polyhydroxyaldehydes or ketones, or the compounds which produce such units on hydrolysis. Let us see some example which follows the general formula of carbohydrates CmH2ON with some exceptions. For example, glucose having the general formula C6H12O6, which fits to the general formula C6H2O6, where M equal to N equal to 6. Acetic acid is an example which has the general formula which fits to the general formula of carbohydrate molecules, but it is not a carbohydrate. Rhamnose is an example having the formula C6H12O5 is a carbohydrate but doesn't fit to the general formula of carbohydrate. So next topic of discussion will be our classification of carbohydrates.